Okay. Number 7 on this chapter review. This is talking about velocity or displacement, and it says a school bus takes 0.53 hours to reach the school from your house. What's the 0.53? Okay. And if the average velocity is 19 kilometers per hour, what's its displacement? This is where you can use this plain small formula, because you already have the average velocity, okay? And you're going to rearrange this formula by doing this. And so D is going to be equal to T times V. You're going to say 0.530 hours times 19 kilometers per hour. And notice that your hours cancel. Remember I said you got to show your units? That's how you check yourself. And you should get 10.07 kilometers. Now, I'm gonna round that to 10.1 because there are 3 significant digits here and 3 here. So I need to round this to 3, and that's your answer. Now turn over to number 16. It's on page 69. Okay. 16 is an acceleration problem. We have something traveling in a straight line with a velocity of positive 5.0 meters per second. Why did I put an I there? And after an acceleration rate of 0.75 meters per second squared, the car's velocity is 8.0 meters per second. We want to know in what time interval this occurred. Now, we have this equation. Okay, we can change that to say change in time. This will be the whole time interval, okay? And since we're trying to find time, we're going to multiply times time on both sides and then divide by time. Then divide by acceleration. So we end up with this. So my time's going to be equal to 8 meters per second minus 5 divided by 0.75 meters per second squared. And what happens is meters per second cancel out. All that's left is a second. And we have 3 divided by 0.75. And we end up with 4.0 seconds. That's my answer. Any questions about either one of those? Pardon me, hon? Now, I'm going to work one with you, number 30, on the next page. No, my bad. Let's do 20 first, okay? Number 20. A car traveling at 7 meters per second, that's my VI. It accelerates at a rate of 0.80 meters per second squared over a time interval of 2 seconds. And we want to know what VF is. Now this is not hard, but people make it hard just because of rearranging algebraically. This is 20. We're using this equation, okay, but we're solving for that. So how do we do that? We're going to say multiply both sides times t. That's going to get rid of that. Then we're going to say TA equals VF minus VI. What will I do with the VI? add it. So this is actually the formal equation. That is a formal equation that is often used when finding VF. And it's just a rearrangement of that original equation. So you don't have to memorize a ton of equations. You just have to be able to do the algebra to rearrange, okay? So we're going to say VF is equal to 7 meters per second plus 0.80 meters per second squared times 2 seconds. Now, look here. This second's going to cancel out one of those, so our units are going to end up to be meters per second, and all you're doing is adding them.
Did you put the decimal in the right spot on that point already?
No, I did not, sweetheart. Thank you. And your answer should be 8.6 meters per second. Because 2 times that's 1.6 and add it to 7, you get 8.6. Is anyone confused? Okay.
But I'm not going to explain that.
Okay, sweetheart, when you get to do the problems yourselves, I'm going to give you time in class to work on them. I'll help you, okay? Are we ready? Number 30. Now, number 30 is free fall. Okay? You with me? Free fall. That means, what acceleration rate am I using? Gravity. And Cambridge, Brown's gravity, which is, you understand that G is equal to an acceleration, right? I need to make sure you know that, okay? Gravity, in most all your college physics classes, you'll have 9.8 meters per second squared. I don't care which one you use. But Cambridge, I'm telling you, on a test is going to give you 10, or it's going to be in a data booklet for you. It's going to be 10 meters per second squared, but usually we think of it as 9.8 meters per second squared. Okay? So a worker drops a wrench from a tower. We have a displacement of 80 meters. Okay? What's the velocity of the wrench when it reaches the ground? Now, we're using this equation again, but this is G. Are you with me? What is the velocity of this object I'm holding in my hand before I drop it?
Zero.
Okay, so I have 10 meters per second squared here. I want to know what that is. That's 0, and I have, oh my bad, okay, that's all right. I'm going to show you a different way to do it. I'm going to give you a different equation. Okay, we're not using that equation. And this is G. And I can derive this for you out of a couple of equations, but I'm just going to give it to you right now. Okay? And what are we looking for? We're still not using the right one, are we? Yeah. Okay, we're looking for this, and we said this is 0. If that's 0, this is my equation, which actually ends up to be, okay, because the VF was squared. Our initial velocity was 0, so we just get rid of it. Because you'd be adding it to something, it would have no significance since it's 0. So the square root of 2 times 10 times 80. The answer should be 40 meters per second. Okay? Now, these are the problems I want you to work. Let me stop this. Well, I'll go ahead and put them on here now. On page 68, 8 through 9. on page 69, 10, 11, 17, and 18. On page 70, 19, 21 through 25, and 31 and 32. Okay? You have the rest of the class to work on them, and you have tonight. I want them turned in tomorrow. Okay? I'm going to check them tomorrow. And I'll pull up the answers, and I'll put the answers down for you, just the answers, so you know. Yeah. I'll put the answers down for you so you know exactly what you should be getting.